back, and so now we want to talk about polarization. And before we do that, let's discuss what light is. So light was caused by an accelerating electric charge, and then it produces a electromagnetic field. So, for example, we know that a charged particle will create around it a field. So just like the Earth creates around it a gravitational field, an electrical charge creates around it an electric field. Then we also talked about magnetism, and we found that something like, for example, a bar magnet that has a north pole and that has a south pole, it's going to create around it a magnetic field, which we said was the letter B. So if you have a charged particle that is accelerating, these two fields get entwined with each other. And so it looks something like this, where the electric field is going up and down, and notice this would be the wavelength of that particular kind of light. And then the magnetic field is going to be perpendicular to it. So it's going to be doing that. So if the electric field is oscillating like this, then the magnetic field is perpendicular to it and it's oscillating like this. And then the whole thing is coming towards you. So in this picture, the light is going in this direction. But that's what an electromagnetic wave is. It's partly electro and it's partly magnetic. Well, it turns out that there is a device that will selectively allow light to go through it, and that's going to be called a polarizer. And so what a polarizer is it's going to be a piece of plastic that has crystals embedded in it. And then those crystals are oriented like this, and then those crystals will only allow light if its electric field is oriented with the crystals. So it's going to block other orientations when it tries to go through that thing. And you can think of a polarizer as being kind of like a picket fence. So that in the first picture there, you got the picket fence, and you thread a piece of string through it, and then you take the string and you go up and down with it. Notice it has no problems with that. So it goes right through the pieces of wood as long as the string is oriented in the same direction as the slits. But look at the second picture. In the second picture, we've taken our slits and we've turned them sideways like this, and we still try to make that rope go up and down, and you'll notice that it can't do it. So it's blocking it in that particular direction. So if you want to see it in action, you've got this thing here, optics.com, and so I just happen to have it here. And so this is showing light, and it's going through this first slit, and now notice that it's being polarized. So originally, notice that you had some of the light that had its electric field going up and down, and then some of the light might have its electric field going in this direction. But when it goes through that first polarizer, that first slit, you notice it's canceling out everything except the electric field that's straight up and down. Okay, now look at the other other three polarizers, and you notice there's no big deal, because the other polarizers are also polarized straight up and down. But look at what happens if I take my second polarizer and I start to turn it. You see the amplitude here is getting smaller. And finally, if I turn it so that it's sideways, I can get it to the point at which no light is going through it. If I do it right, there it is. So now this one is perpendicular to this one, and you see that no light is getting through. So it's like having two picket fences, and now they're oriented like this so that the light can't get through it. Okay, let me put this one away, and let's go back to here. So I wonder, is there any usefulness to this particular property, polarization? And yes, there is. So it's going to be polarizing sunglasses. So I want you to have an understanding for how polarizing sunglasses work. The light that is coming out of the sun, some of its electric field is straight up and down. But some of the light coming out of the sun has its electric field like this. And some of it has it like this. So if we wanted to illustrate that, we could use it with arrows that would be pointing up and down, pointing sideways, pointing at an angle. So the light is coming straight at you. And this is the direction of its electric fields. So we would say that the light that's coming from the sun is unpolarized. It doesn't have a particular direction. And so that's the reason why there's that kind of a star thing. That's the polarization of the light coming from the sun. And the problem is that when it is reflected off of surfaces and then goes into your eye, you see glare. So in that first picture there, off to the left, you see what the bottom of a creek bed looks like. And you notice that you're seeing also a reflection of the sky in the water. That's bad. So we want to get rid of that glare. So how do we do it? We're going to wear polarizing sunglasses. So it just so happens that when light bounces off of a surface, it becomes at least partially polarized when that happens. So when this unpolarized light bounces off of a surface, it then becomes polarized. So that's the reason why I drew the line sideways. It's now been polarized as it goes through there. So now what you're going to do is you're going to wear special glasses, and the lenses in the glasses are made of Polaroid, and so they're polarized so that they are up and down like this. So that when this glare goes through these glasses, it's reduced. And so if you look at the second picture there on the top, now you can see the bottom of the creek bed much easier. So it got rid of the glare. And so that's how polarizing sunglasses work. Now I encourage you to do this little experiment. Get some polarizing sunglasses, go outside, find some glare. So sunlight bouncing off a car window or something, and you're seeing some glare. Okay, put on the glasses, and you'll notice the glare is reduced. Okay, now take your head and go sideways with it if you can. So, or take the sunglasses and turn them sideways, whichever is more comfortable for you. And when you do that, you're going to notice the glare comes back. So polarizing sunglasses are designed to be worn in only one way. And then if you take the glasses and you tip them over, that is going to allow the glare to come through. So I encourage you to try that. Okay, let's take a break, and when we come back, let's take a quiz over this material.